Okay, you've seen these patterns before, but I don't think you've seen them in the way I'm going to present them. And I feel like this method I'm going to show you really does make a huge difference in your ability to remember the pattern. Okay? And then we'll practice a little bit. As I show you the patterns, it should feel, love the rain. I actually do love the rain, so it's not exaggerating. If it's just the rain, I told you I'm like the dog Doug, right? It's a real thing. I'm not kidding. Like I can't keep track. Like, oh, the rain, nice. What are we talking about? So anyway, the patterns I'm going to show you should feel familiar, but just stick with me. I'm hoping that I show you enough of the pattern that you go, oh, that is easier to remember. And where I like to start is with the clock. Okay, everyone's seen a clock before, so that's something you can connect your brain to. Let's say it's all about connection. So, there are some numbers you need to memorize. Here are the numbers you need to memorize. The nice thing is they are a pattern as well. Okay, it's not that hard to memorize the sequence 1, 2, 3, right? Simple. Okay, don't think too long, just say it out loud. Which of those three numbers is largest? Say it. 3. So if I do this, okay, don't think too long, just say it out loud. Is the first, second, or third value largest? Say it. Yeah, not quite as confident on that one. Okay. Square root of 1, no, think about it. Square root of 1 simply means what times what is 1? The answer is 1. So what times what is 1? The answer is 1. I promise calculus will get harder. Okay. What times what is 2? I don't know, but it's bigger than 1. Okay, so this is the largest. It's just what your intuition would tell you. There's nothing secret about it. That's why I say memorizing it should be easy. So, just 1, 2, 3, smallest, middle, largest. Questions? Everybody good with that? Okay. Turns out when you have a clock, if this distance here, if the radius of the clock has a distance of 1, okay, it turns out that those values, if you divide each of them by 2, appear on the clock. So those are the three values that you have memorized in the past. You need to make sure you have them memorized today and never forget them. It's not really calculus. It's just something we use in calculus, and we don't want it to get in the way of the calculus. Okay? So I'm trying to show you a simple way to have it memorized. So three values, 1/2, root 2 over 2, root 3 over 2, small, middle, large. Okay? Questions about anything? Awesome. Okay, those values show up on the clock. Here's where they show up. If you're right here, and you start at the center and you draw a triangle to that spot, you have to go over some distance, and then you have to go up some distance to get to that spot. You're creating a triangle. Okay, the radius of the triangle will be 1 because it's a circle. So the radius never changes, it's always 1. The distance up, being a short distance, that's this, 1/2. The distance across, being a long distance, that distance is root 3 over 2. Okay? Have to have that memorized. You will use it throughout the year. Questions? And now it doesn't matter where I go on the clock, that pattern never changes. Like I can go here. The radius is still 1. But now, the distance over is the short distance. And the distance down is the long distance. Not drawing that real well, but the number didn't change. The distance down is still root 3 over 2. The short distance is still 1/2. Anywhere on the clock, that is true. Questions? Cool. Okay, so the next thing to memorize, this one, this is the middle value, which is very convenient, because if this is the middle value, that occurs when you are in the middle. So if I'm right here between 1 and 2, the radius to that spot is still 1 because it's a circle. But now I'm right in the middle of the arc, which means the distance over and the distance up and down is exactly the same. So that blue distance, that's this one, root 2 over 2. Okay? Questions? Okay, how this all ties to calculus is as follows. So you've got that memorized. So now I can erase it. Well, yeah, we'll leave that there. These spots on the clock also correspond to angles. So every number on the clock is an angle. This is an angle of pi divided by 6. This is an angle of, notice it's exactly twice as far. So that's an angle of 2 pi divided by 6. Or reduced, we say that's an angle of pi divided by 3. So this is where it's to start feeling familiar. Questions? Awesome. That means you can find any angle on the clock simply by counting. So if I've got to go find an angle of, say, 7 pi over 6, there is absolutely no need to stress. I just count. 1, 6, 2, 3, 4, 5, 6, 7. So that's where I'm at. That's the angle. So if I'm working a calculus problem, and as I'm working the problem, I'm suddenly needing to know what is the cosine of 7 pi over 6, I don't panic and say, dang, I can't remember the unit circle. What I do is I just look at my watch that I happen to have worn to the AP test because it's legal. I'm not kidding. I look at my watch and go, oh, 1, 2, 3, 4, 5, 6, 7, I'm right here. And then I say, okay, so that means there's a distance over from the center. And there's a distance up and down. The distance over is the long distance. So that's root 3 over 2. I went to the left, therefore negative, and I just keep doing my work. So I don't remember the unit circle, I remember the clock. It's just my method. So, because I see a clock every day. I don't see unit circle charts every day, but I look at the clock all the time. So just my method. Question. So I'm doing the sine of 7 pi over 6. That's the up and down, but it's the short distance. That's 1/2. But I went down, therefore negative. So that's how I solve any calculus problem that involves sine or cosine of some angle. Just count it on the clock. Questions about anything? Okay, let's practice together here for a minute. So, let's do this. If you're working a calculus problem, and you've got to find, say, the sine of, we'll go 11 pi 6. If you're using this method, I want you to use your hands. So you can go from 0, this means 0, this means 10. And show me with your hand or hands what number on the clock should you be looking at. Show me. If you're working a calculus problem and it says find the sine of 11 pi 6, just do it like this so not everyone can see. So it's kind of like your own little private answer. So show me on your hand what number on the clock should you be looking at? If you don't know, you go like this. That tells me I did a bad job of explaining, and then we'll talk some more. So if you are doing this, you're going to mark on your tally mark 4 points. So mark down 4. If you need me to show it, you just go like this. You don't have to announce to the world. You just go, "Okay, I can't see it. Please show me again." So no one is waving. It's like an auction. You just twitch and I redo it. So we're looking right here. So here's the angle. So let's make a little list here. So A is 0. B is 1/2. C is root 2 over 2. And D is root 3 over 2. And E is going to equal 1. So you go to the right spot on the clock. You go to the center, you go over some distance, and you go down some distance. The distance over corresponds to the cosine. The distance down corresponds to the sine. So now you're going to show me on your hand. This means A, B, C, D, E. I don't have a clue. Don't worry about the positive and negative yet. What goes in the box? A, B, C, D, or E? Show me. What goes in the box? A, B, C, D, or E? If you're doing this, give yourself 2 points. If you need me to show it, go like this. Okay, so are you okay that we're looking at that spot? Okay, so we just look and see the distance over, and we compare it to the distance down. Sine is always the distance up and down. The way I remember that is, there's an eye right here that looks up and down, kind of that helps me. Also, this is what a student told me. The cosine kind of looks like the word across. It's not exactly, but enough to remember. So the cosine looks like the word across, so it's always the back and forth distance. So this distance here, that's the short distance, therefore 1/2. Say it out loud, please. Is it positive or negative? Say it. Negative. Went down. Okay, if you went like this and it helped, go like this. If you went like this and it didn't help, go like this. So, okay. Questions? Okay, one thing about my class. Everybody look here. Everybody look. Okay, as I said on the first day, and I'll keep saying it, this class is not at all about demonstration. It's not at all about you just copy what I do. You will not be successful on the test if you do that. You'll get really frustrated. The class is all about understanding the idea. Now, right now, we're just understanding some patterns to help you memorize something. But you still need to understand it because then the memory will stick. In my classroom, there is nothing wrong with ever just raising your hand and saying, I don't really have a question, but I got to see it again. And I'll just try to show it a different way. Okay, so don't ever hesitate at all to just say, slow down, give me a chance to write something down. Don't ever hesitate to say, I don't know what to ask, but I'm not really getting it. I can relate to that completely. I've been in lots of discussions where I couldn't follow what was going on. I didn't have a question. I just needed them to slow down. Or I just need to kind of like, can you do it again? Can you show me differently? So you ask about that anytime. Okay. Please, John. Yep. There's another way to memorize that I think is helpful. Stay with me. Now, I've said John's name twice now, so he gets 2 points. John, there's the third. In the alphabet, which word comes first, cosine or sine? Perfect. There's 4. In the alphabet, which word comes first, horizontal or vertical? Convenient. Horizontal comes first, cosine comes first. Perfect. That makes sense? Yeah. More patterns, the better. The more you'll remember it. So, anybody else? I really am against like blind. Okay, it's just like the names. It's why I can remember Parker Simmons better. There's a connection. It's easy. Okay. And as soon as I remembered Bell, it's now easier to remember Marielle. So it rhymes too. Okay. Did your parents do that on purpose? Just kind of worked out. Yeah, I get you. Yeah. Other questions about anything? Okay, let's practice another one. So can I erase this and start fresh? Awesome. Clear that off. This one you'll have to raise your hand. Well, no, let's try it. What the heck? See if you can use two hands to show me. Use two hands to show me in some way where should you be looking if we're trying to find the sign of pi over 4. See if you can come up with a way to indicate with your hands where in the clock should you be looking to identify. Yeah, it's kind of, I don't know how I show it on my hands either, but I'm kind of liking, tell me your name again, I forgot. Right here. Isaac, last name? Erwin, there we go, Isa's brother. So Isaac's got a creative method, I like it. So how do you show that? Where's that on the clock? Show me with your hands. Do something. Yeah, I like that. John's got a good way. I'm thinking that's good. I get that one. Dallin Larson, I got that. Riley Barrett's looking good there. Something Turley. Landon, sorry Landon. I'll get your name, I promise. So you should be looking here. Okay? That's 1 pi over 4. That's 1 pi over 4. Okay? This class is all about honesty. Abby Christensen was kind enough to make me a nice sign about that. Because your test is 80% of your grade, it doesn't matter how many freaking little points you get. It's not going to matter a thing. So I just trust you to be honest. So raise your hand if you understood this was the spot. Show me hands. Point for that. Okay. Here's the pattern. It's a little weird. We won't worry about the details of it, but it's all about the fact that the distance around a circle is 2 pi times the radius. That's the circumference. Therefore, the angle all the way around is 2 pi. So the angle halfway around, it's kind of weird, but the angle halfway around is 1 pi. Therefore, that's 1/4 of the distance around. This would be 1/4 of halfway around. This would be 3/4. Questions? So raise your hand if you can tell me this. Don't try to show me with your hands, just raise your hand. Where should you be looking on the clock if we're dealing with sine of 5 pi over 4? Just raise your hand if you know. Where should you look? Where do you look on the clock for sine of 5 pi over 4? So, shoot. Mitchell, yeah? Michael. Dang. Michael Franson? Where are you looking, Michael? Perfect. So, show me your hands if you knew that. Point. Michael's got 3 because I said his name 3 times. Okay. Questions? You would need to see it again. Just wave. We're looking good. Okay. The angles that involve a fourth, they're always in the middle. So I just know this is root 2 over 2. So like this. This one's also root 2 over 2. Now I just have to look at whether I went up or whether I went down to get to that point. So right here I went up, positive. Right here I went down, negative. That's the pattern. Questions? Cool. Let's pause that. Well, let's just do a couple more practice here. So let's go back to this. So we have a 0, 1/2 root 2 over 2. Cool. Let's get rid of this. Show me with your hand what your answer is. A, B, C, D, or E. Show me. What is the cosine of 5 pi over 6? Just show me A, B, C, D, or E. And the goal here is to get you to be relatively quick. Like what I do is I look and I count, and then I can see it. Like I have to count first, but once I count, I've got it. So if you're doing this, give yourself 4 points. Go like this if you need to see it. Okay. So 5 pi over 6, I just count my spots on the clock. 1, 2, 3, 4, 5. So there's the angle. Cosine looks like the word across. So I'm paying attention to the distance over. That's definitely negative, and that's definitely the large distance, hence root 3 over 2. So I kind of messed you up probably because I didn't have the negatives there. I apologize for that. Good? So if you went like this, give me thumbs up or thumbs down so I can kind of see. Okay, good. Questions? Please, John. We always start on the 3, actually. And the idea, again, is that a full rotation halfway around is pi. So if you divide that up evenly, you get 6. That's why this is 1/6 of the rotation. If you divide it into fourths, you just keep asking until it really clicks, John. Just ask as much as you want. That's why it's considered a fourth of pi. Does that help? Yeah. Point. Anybody else? Please. Perfect. Tell me your name again, sorry. Sydney Larson. And I don't know anybody. If I know siblings, just keep reminding me of your siblings. It helps. Okay. That's right. I got to look up his picture again. Okay. Let's do that one together, Sydney. Let's say, I think this will answer your question, Sydney. If it doesn't, we'll just keep talking. Okay, show me your vote if you know the answer to what goes in that box. Which of these, A, B, C, D, or E, go in the blue box? If you don't know, go like this. It's fine. It doesn't bother me. If you're doing this, give yourself a point. Okay, it's back to what we were saying to John. There's another point for John. There's 2. You really want to raise your hand because then your name gets stuck in my head. And then I say it over and over again. You just start marking down tally marks. So there's 3 for John. From here to here is a rotation of pi. Therefore, from here to here is a rotation of 1/2 pi, or pi divided by 2. So that's the angle. From the center, I don't go across at all. I just go straight up. So the cosine value is 0. The sine of pi over 2, that's going to be 1 because I went straight up. Sydney, did that help? Okay. Did you have a sister as well? What was her name? No, different family. So the one I'm thinking is Zach isn't Zach, so I got to find a new picture in my head. So, okay. Anybody else? Awesome. Cool. I got to practice the names again, then we'll go to the next topic. So let's pause the video for just a second. Okay, this handout is not homework. There was just some things that we need to talk about and understand that I felt like if you have to draw them out, it kind of makes it harder to have your brain focusing on understanding. So I felt like it would be very helpful to have a good amount of information in front of you. Now, you'll probably add a little bit to it, but this way you can focus on making sense of the idea and not get bogged down in like taking notes. So this goes in your 3-ring binder. It's not homework. There's no homework tonight. You will find that happens periodically in this class because the goal is not to have you do problems. The goal is to have you understand ideas. So we're going to talk about the ideas in this packet. No homework tonight. We'll continue talking about this packet on Monday, and then there will be homework on Monday. So you're welcome. You're welcome. There's two of them there. So. We'll do it kind of together. Once we get there, it's just kind of practicing together. It's just not homework. You already have one, right? Okay. You're welcome. Okay. Okay. Okay, quiet, please. Okay, real quick, extra credit opportunity. All you have to do is raise your hand. If I cannot come up with your name in about 5 seconds, you get a point. So Nathan Ashton, Rachel Jemmett, Katie Rands, Sydney Larson, Hannah Bartholomew, John Langford, Luke Hayes, Chris Billings, Harrison Pope, Kate Crofts, Grace Coford, Kate Spencer, Caitlin Carroll, Lily Gray, Haley Pedroza, Ruth Glass, Landon Turley, Spencer Olson, Luke Lenhoff, Anna Hunt, Dallin Larson, Nathan Crofts. Was that wrong? Shoot, Nathan Ashton. What? I'm confused. Now you got me off. Taryn Marriott. Taryn Marriott. 5 seconds is a bit of time. Make your best judgment. Ben Acey. Julian Wisman, Elijah's brother. Michael Franson. Parker Simmons. Okay, cool. All right. All right, here we go. Okay, again, look here. I'm going to keep reminding you, so I apologize if it gets tiresome. You just cannot forget. The idea here is not how to learn how to do step-by-step some problem. The idea here is to understand ideas. You internalize those ideas, and then they'll be used to solve problems. So at this point, we're not solving anything. We're not answering AP questions. We're just internalizing ideas. All that stuff we did with the clock, that's just trying to get to the point that you can recall some key information quickly by connecting it to something. I'm not joking when I say if I were you, I would go home, I'd get on Amazon, I would find the largest, legal wristwatch I could, like a real watch, with a dial like that, and that way when I'm taking a test, if I run into sine of 7 pi 6, I just look at my watch and go 1, 2, 3, 4, 5, 6, 7. I go, that's got it. That's what I would do. It's perfectly legal. So, but anyway, so same thing here. We're not solving anything. We're just learning ideas. The ideas I'm going to talk about initially, those are not new ideas. It's just kind of quick review. Here we go. In calculus, we are always studying either a function or a relation. Okay, it's not really that important that you know the difference. In previous classes, they may have tested you on the difference. For our class, it doesn't really matter. Okay, all you have to remember is when we are talking about a function, what your brain should be visualizing is a big long list of numbers. And they're always number pairs. That's the key. So we start talking about a problem, you've got to immediately think of, I'm keeping track of two things simultaneously. a pair of numbers. Okay, and it's just a list. They go together. You've done that before, but just need to emphasize that. I need to emphasize that you need to look at graphs differently than you have in the past. Okay? In the past, typically when students look at a graph, they see lines, they see curves, they see parabolas. For this class, you will do far better if you forget about all of that and you just look at the graph and say, I see dots. There's just so many of them, they look like a line, but they're not a line. They're just dots. Every dot has an XY number associated with it. Don't pay any extra attention to the big dots or the open dots. They're just points as well. They're just there for kind of visual emphasis. So when you look at a graph, it's just an infinite number of dots. That's it. Questions about anything? Okay? I'm going to remind you again. Don't pay extra attention to the open circle or the closed circle. There's nothing special. This is just a dot, just like this is a dot. They just didn't emphasize the green one as much. But they're both just dots. Okay? The open circle, that's just a missing dot. That's no different than this spot right here. There's no dot inside that box either. There's no dot inside that missing, that circle. That's there just to show you that there's nothing there. The open circle is showing the absence of a dot. Okay? Questions? Don't think of it as a whole. I know some teachers in the past have called it that. That will cause a little bit of problem in this class. It's just a missing point. Okay. Awesome. All right. Tables. When you see a table, it's again just a list of XY values. Nothing special about that. There is one thing important about the table, and I have flashcards on the desk because I have found that students who get really good with their flashcard deck do really well on tests. So I'm going to encourage you highly to get a really good flashcard deck. I'll kind of prompt you when I feel like you should make one. Here's the moment I'm now prompting you. This is a really silly flashcard, but you'd be amazed at how many test questions this will save you from missing. Okay? So don't write anything yet. Understand first, then you memorize. So one side of the card needs to say something like table question mark. Like, what am I supposed to remember about tables? Or maybe that's what you write on one side. What I should remember about tables. Or, key thing about a table. Something like that. You choose, I don't care. But one side should indicate something you're trying to remember about a table. There are lots of AP questions that use tables. The thing you should remember is, I have never seen an AP question where the table showed anything more than what are known as selected values. So one side of my card says table question mark. So I look at that and go, what am I supposed to remember? I'm like, that's right. I'm supposed to remember tables only show selected values. That's what I write on the back. So tables only show selected values. And I've seen AP questions where if you forget that idea, they will successfully trick you into choosing the wrong answer. Yeah, guaranteed. So, questions about anything? Please. So here's a good example. Luke Hayes, yes? Perfect. 2 points for Luke. Selected values means the following. This is the y-coordinate when the x-coordinate is 0. This is the y-coordinate when the x-coordinate is -4. If I were trying to draw a graph of that thing, I'd be like, okay, here's my graph of g of x. When x equals 0, the y-coordinate's 8. When x equals 1, the y-coordinate's -4. But there are an infinite number of xy values in between those. So go ahead. Right. So the table is showing you selected values of the entire list. So the function g of x is an infinite list of xy pairs. The table only shows a few of the xy pairs. And the word they'll use is they'll say, this table shows selected values, like values that we have selected to display. Did that answer your question?
Yeah. And then we can imagine that like all like there's just lots of tons of little dots connecting between like the dots they show in there, right? That's what it is.
Yes. 2 points for Taryn. If I get your name wrong, tell me. Okay, listen to what Taryn said. There's another point. There's a dot here for sure. There's a dot here for sure. The key thing, everyone listen, the key thing is you don't know where the other dots are. So maybe the graph is crazy. Maybe it like oscillates up and down. Maybe it goes nice and smooth from, dot to dot to dot to dot to dot. You just don't know. So when you're answering a question, don't assume unless you have other information that would tell you something else. That's how they try to trick you. Does that make sense? Yeah, it's a good question. Anybody else? Awesome. This can be a little confusing. If I say the function f of x, that usually means I'm referring to the entire list of xy values, all of them. But in other statements, when I say f of x, I may only be referring to the y coordinates. That can go either way. It just kind of depends on the context. So, questions? Cool. On the AP test, you'll see this over and over again. They'll give one problem where you're asked to deal with a formula. They'll give a different problem where you have to deal with a table. Different problem you have to deal with a graph. They do it all the time throughout the entire test. Just keep switching it up on you. So, one thing I like about AP Calculus, I don't recall any AP problems ever since about the year 2003, so the past 18 years, where you had to graph anything. I've never liked graphing. I was very grateful to grow up in the era of computers where I just tell the computer to graph for me. So we don't really do any graphing in this class. We have to understand graphs, we don't graph them per se. So, questions? Cool. Okay, so that's the background. Now let's talk about a calculus idea. Oh, no, sorry, still back on a little bit of background here. So if we're asked to find f of 3, that means we are finding a y coordinate. But they're telling us that the x coordinate we should be focused on is an x value of 3. So when they say f of 3, that means literally, please tell me, when the x coordinate is 3, what is the corresponding y coordinate? So you're going to show with your hand again, just so I can see if you're following what I'm talking about, what would go inside the blue box if this were the graph depicting all of the xy pairs which comprise the function f of x. So show me with your hand what goes in the blue box. What goes in the blue box? If you're doing this, give yourself a point. What I would do is I would look over here and say when the x coordinate is 3, the dot that corresponds to an x value of 3, the dot that has an x coordinate of 3, because remember every dot has an x coordinate and a y coordinate, that same dot has a y coordinate of positive 1. So this would be 1. You wouldn't want to talk about it. Perfect. Okay. If they say this, okay, remember, we just constantly talk about x versus y over and over again. So in this situation, they are telling you the x coordinate, and you had to go figure out the y coordinate. This symbol represents the y coordinate. Now they're saying, hey, we're telling you what the y coordinate is. The y coordinate's 3. Tell us what belongs here. Like what would the x coordinate have to be so that the y coordinate is 3? That's what they mean when they say solve this equation. So look at this graph again. Show me on your hand, what would the x-coordinate need to be in order for the y-coordinate to equal 3 as best you can tell? It's not perfect, but as best you can tell, show me what would the x-coordinate have to be so that the y-coordinate is 3. If you're doing this, give yourself another point. So now we're looking here. Right there, the the y-coordinate is 3. And that dot has a corresponding x-coordinate of 1. Hence, this statement is like saying f of 1 has a value of 3. The 1 is the x-coordinate. The f of 1 is the y-coordinate. Okay, questions about anything? We use function notation all the time. That's why we have to start with this idea. You've learned this before, but we have to start here to get to the calculus. So. Awesome. You can do the same thing here. Show me on your hand if you know what goes inside of the red box. If this is the function, at least selected values of the function g of x, show me on your hand what goes inside the red box. If you're showing 5 fingers, give yourself 5 points. Because this is saying this represents y-coordinate when the x-coordinate is 3. When the x-coordinate is 3, the y-coordinate is 5. So, questions? Cool. It says solve the equation. Solve the equation means find the value of x. That will make that a true statement. So show me on your hand what value of x will make this true. What value of x will make that statement true? Show me with your hand. If you're showing a 0, give yourself a point, because I don't want to say give yourself 0 points. That makes no sense. When the x value is 0, the y value is 8. So this would be 0. Questions about anything? Please. Oh, good question. Hold on a minute. Hold on. Harrison Pope, yeah? Point. So here's an example of what Harrison is talking about. There's another point for Harrison. Right here. For this function, if we called this function f of x, and we said go find the y-coordinate on the function f when the x-coordinate has a value of a, we would say here's the x-coordinate, but at that x-coordinate there isn't a y, there's no dot. So there is no corresponding y-coordinate. So the word they'll use here is this is undefined. So different wording, but exactly the same idea. Is that what you meant? Yep. Yeah, they'll ask that. That's not uncommon. So, anybody else? Okay, let's go back to here. Okay, now we're ready for calculus. Yeah, please.
Undefined, would they ever ask us to define it using two limits?
Oh, no. They'll ask related questions, which we're kind of going to discuss now, but they won't ask you to do what you're saying.
Okay.
Is that okay?
Yeah.
2 points. Anybody else? Okay. The wording in number 4, to me, is a little hard to digest, but I had to write something down to get us started. So this wording says the following. Right here. Okay, the way you read that red box is you say the limit, so LIM is an abbreviation for limit. The limit as the x-coordinate is getting very close to equaling b. So the limit as x approaches b is how you say that. It's crucial that you never think of the arrow as an equal sign. It isn't. It's crucial that you notice this right here. The x-coordinate gets very close to equaling, but it never equals. So in this example, we have to be thinking of the x value as being almost b, but we must be careful to make sure it is never actually b. It's always close. That's what limit means. Questions? Okay, so keep reading. So it says the limit as x gets close to b of the function f is equal to 1. What that means is that for the function f, if you choose an x-coordinate that is almost b, so I'm going to go to a different picture here that's a little bit bigger. So if we look at this picture, nice and large, let's even make it larger, will help some. There we go. So I go to an x-coordinate that is almost b. That means I'm looking like right here, as best I can draw, an x-coordinate that is almost b. And I notice that if my x-coordinate is almost b, let's put a scale on here. Let's call that 1. We'll call this 3. It's a reasonable scale. 2 is about here. So if I'm in an x-coordinate that is almost b, the y-coordinate there is, it's not exactly 1, but it's almost 1. Okay, that's what we mean when we talk about a limit. We make the x-coordinate be almost something, and then we interpret what is the y-coordinate almost. Okay, it's never equal. It's like, what is it getting close to becoming? Question. Okay, there's one thing I was hoping somebody would mention. No one did, so I'll give a little hint, see if you can pick up on what I'm thinking. If I'm supposed to pick an x-coordinate that is almost b, there's a flaw in my reasoning. Like I picked an x-coordinate that was almost b. It's right here. It's the green one. That green x-coordinate is almost b. But there's a flaw. I've got to think of something else. Hands up if you can kind of guess what I'm thinking. Come on. There's a few people. Like, what am I missing? I'm supposed to pick an x-coordinate that is almost b. I did. But I think someone could come along and say, wait a minute, you forgot about something. Anna. Perfect. There's actually 2 x-coordinates that are almost b. There's the green one. There's also the red one. And they have 2 different and distinct y-coordinates. Okay, how many noticed that? Show me hands. Point. Questions. Okay, so when we talk about a limit, we're talking about the limit as x approaches b of the function f. We actually have to consider always, there are no exceptions. When you're finding the limit as x approaches b, you are always thinking of, hey, wait a minute, the x-coordinate could be a little more than b or it could be a little less than b. You must consider both of them. So let's change the color on this to hopefully make it a little easier to follow. That's not the right button. Let's go back. Let's erase this and just redraw it. So if I'm making the limit, I'm trying to find the limit. Come on, blue. I'm trying to find the limit as x gets close to b. Your very first thought should be, I cannot do that. The best I can do is go investigate what happens when x is a little less than b. That would be green. You write that like this. Okay, it is crucial that you learn to use this notation. Half of the AP test is written. If you don't use correct notation, you will not get any points. So this green line is what I've written here in green. I'm finding what's happening when the x-coordinate is almost b, but it's slightly negative of b. It's known as the left-hand limit, because you're just a little bit left of b. The red line is the right-hand limit. It's the limit as x gets close to b from the right-hand side. Okay. Questions? Please, John.
So, why is it negative when it's greater than that? Why is it really
Let me see if I can get you to see it for yourself. If I'm sitting at an x-coordinate right here, is that x-coordinate a little negative or a little positive of b? Just a little bit negative of b. It's like a little bit less. So that's this one. Did that answer your question? 2 points. Please. Oh, Hannah Bartholomew. Okay. 2 points for Hannah so far. The thing to me, like everybody must memorize this. You must memorize the following. When you are asked to find what I refer to as the overall limit, you never find that. You always go look at the left and right hand limits. So you don't ever look at this. You say, I can't answer that. I can answer the green and I can answer the red. So you don't ever do the blue, you always do the red and the green. And here's how you do it. You say, well, go back to what John was saying, point there. If this x-coordinate is almost b, the y-coordinate is almost 1. Okay, it's not exactly 1, but it is getting very, very close to equaling 1. In fact, the closer that I make the green x-coordinate, the closer that value becomes to actually being b, the closer the corresponding y-coordinate will be to equaling 1. Therefore, the left-hand limit in green is equal to precisely 1. Because limit means what y value are you getting close to equaling? Not y value do you equal, what y value are you very close to equaling? So I told you I'm like the dog Doug, and that distraction is not a problem because that happens to all of us. Questions? Can I answer your question, Hannah? What happens is so if it asks for the blue, you're doing great, Hannah, 2 more. If it asks for the blue, you think, okay, I got to go find the green. So that answer is 1. Now I got to go find the red. Well, if I have this x-coordinate, and I get closer and closer to b, the corresponding y-coordinate is still getting closer and closer to 1. So this is also equal to 1. Therefore, you conclude that the overall limit is indeed 1. But the blue is found by studying the green and the red. The blue is not found any other way. Does that help? Please. Listen to what Isaac's saying, 2 for Isaac. Okay. Compliment to everyone. We got like 9 minutes left. Okay, the focus in class has been perfect today. Really, it's just the same thing every day, perfect. You just keep digging to make sense of it. Another point for Isaac, because I said his name again. That's what you have to do. You have to say, wait a minute, that didn't click. Let's just talk some more. Okay. As I said earlier, I forgot who I talked to about it. That open circle is the absence of a point. There's nothing there. But the location of that open circle is very precise. That missing point is at, and I do something kind of weird here, just to kind of emphasize. I go like this. It's not really there, okay? But what's not there would be located at an x-coordinate of b. So it's kind of a dumb joke, but to kind of help you see that it's not really there. And the y-coordinate at that missing spot is exactly 1, but it's not there either. So nothing is there. With me? However, that means that open circle is way too big. Like it's infinitesimally small. Like there's a missing point that's infinitesimally small. If we get infinitesimally close to that point, the y-coordinate will never be 1, but it will be infinitesimally close to 1. And that's what limit means. Yes. What's weird is, see if this helps, Isaac, another point. We use an equal sign here. which seems funny because you're like, wait a minute, it's not equal to 1. It just means it's getting really close to 1. But the difference is the word limit means, please tell me, what are we getting really close to equaling? And we are getting very close to exactly 1. So limit does use an equal sign because that's what you're getting close to. Does that help? Good. Please. Sydney. No. You could find a limit, say, right here, at that spot, because you do the same thing. You'd be down here. Okay, I'm just going to say that's f, since we don't have an f. Is that okay? If you were finding the limit as x approached f, you'd go a little bit to the left. I used the wrong color, but so let's make this blue. So here's right at f. If you were finding the limit, you would go a little bit to the left of an x-coordinate f, and you'd go a little bit to the right of an x-coordinate f. Same idea. And you would conclude that in both cases, hey, I'm getting close to 2. Did that answer your question? 2 points. Anybody else? Okay, make sure you can do this one. Okay, we know that the limit as x gets close to b, that's going to equal exactly and precisely 1. If they say this, change color, find the value of f, which means find the y-coordinate when the x-coordinate is exactly b. So this is another point for Isaac. This is the difference between what is meant by a limit versus what is meant by precisely x equaling b. Show me on your hand if you know what will go inside the orange box. Show me. If the x-coordinate is exactly b, what is the y-coordinate? Okay, so point for the whole room, but I've got you mixed up. So let's talk, hands down. Right here, I cannot look there. There's no point. If there's no point, there's no y-coordinate. But if I look here, this dot, okay, every dot, remember this graph is just a bunch of dots. Get the lines out of your head, okay? It's just a bunch of dots. So let's vote again. So what goes in the orange box? Show me. There we go. Okay, pay attention to how you feel. Like you could tell, right? Like as soon as I gave you just a little clue, your brain said, nope, I get it now. It makes sense. That's what you got to do in this class. Don't follow steps. Follow ideas. You get the ideas down, the steps are a piece of cake. It really is. It's just like the ideas are the part where people get stuck. Okay? So how many did this? Show me. 3 points. Good work. So that dot has an x-coordinate precisely equal to b and a y-coordinate precisely equal to 3. So it's not this ghosty thing. It's a real dot. Like there's something there. Questions? Please.
So if that point was there, would it just be undefined?
Nicely done. Marielle, yeah?
Yeah.
Marielle Sutton. Here's what Marielle just said. Watch how... Dang, I don't have the right color. I was so excited to show you. Oh, well. I usually have a palette that includes white, and then I can make this disappear. It makes me very excited. I don't know why. It's more fun when I show you and it's talking about it. You're like, what's he talking about? Yeah, if that dot is not there, then you would say that f of b is undefined. Perfect. 2 points. Questions? Okay. One more little thing just to check your understanding. The bell's going to ring soon, but just stick with me for just a second. If we are finding the limit as x approaches d, again, we cannot think of what's happening at d. We must think of what's happening a little bit left of x equal d and what's happening a little bit more than x equal d. I'm rushing a little bit because of the bell. But so I do that green-red thing. I could go a little left of d, and then I go a little right of d. They're like, hey, wait a minute. A little left, the y-coordinate's 1. A little more, the y-coordinate's -1. If they're different, this limit is called non-existent. And that's good for today. Good job, you guys. Well done. Good work, you guys. Good work. The idea of a limit is just, it's a mathematician's way of saying, it's really related to what you were talking about earlier. It's just the mathematician's way of saying, we could never find this thing. So let's kind of see what's happening when we get close. Yep. Does that make sense?
Yeah.
Yep. Perfect.
By like the surroundings and all
Yes. So you answered that better than I did. Nice. Good job, Taryn. Well done. What to me is kind of fascinating is the idea that for thousands of years, no one ever thought of that.
about like what you do if you don't.
Right. They just went, we don't know.
Yeah. It's interesting.
Isn't that?
Who first thought of the concept that we should define something that isn't there by what's around it?
Isaac Newton. Yeah. As far as I remember. So I could be wrong, but as far as I remember.
So cool. Seems like such a, oh yeah, duh.
Yeah. But to me, that's what I think is super interesting as well, is there are lots of things in this world that once they were discovered, everyone said, duh. Yeah. The whole hard part is like, how do you figure it out before?
And that's like all math things.
Yes.
And like solar system stuff. You're like, you think about it and you're like, oh, well, duh, this happens. How did they even stop this thing? Oh, maybe like something more happens around us.
Well said. Well said. Good job, Taryn.
Hey, thank you for answering my questions.
You're very welcome. Just keep going, man. Keep going. I don't know how to do the modern
I'll
stuff
go for
there.
the dab. Ready?
Oh, like
You gotta dab.
lad, dap. Oh, slow down.
It's a dab.
Oh, slower. Like that.
Yeah, yeah,
I
yeah.
can.
Grab. It's a dab.
Oh, a dap.
Yeah,
that?
yeah,
All right.
yeah. All right.
All right.
Hey, thank you.
Good job, you guys. You're very welcome. Well done. Well done.
So my mom talked to you about how I'm not going to be here next week.
Yes. What you'll do is get on Canvas, and I don't post it ahead of time because every year is a little different.
Right.
And so, like it's still running. So I make a video of the discussion. So